right, hello everyone, and welcome to the Satellite Book Club Seminar Series number 239. Brian Gockel here from the Office of Observations, and today's presentation is Research-Driven Strategies for Community Preparedness in Managing Glacier Lake Outburst Flood Risks in Juneau, Alaska. Our presenter today is John Osman, Senior Hydrologist from the NWS Alaska Pacific RFC, the River Forecast Center. This presentation was also shown at the American Meteorological Society annual meeting back in January. Our presenter today is Jack Dostalek. Our facilitator today is Jack. And before we get underway, we want to give a few routine announcements. First of all, session being recorded per the OCIO Privacy Act guidelines. Attendees will not have the ability to use their microphones or webcams. Please see the pinned messages in the chat for more info. Q&A session, as usual, will be after the main part of the presentation. Please stand by. Please stay with us for that. We encourage attendees to put your questions, if any, in the chat room, and we'll field them from there. If you're logged in under an alias account, please sign in with your full name or specify your full name when asking a question in the chat. Always looking for future presenters. Please contact the TowerS team if you're interested in presenting. And Emily's dropping a link in the chat, which makes it real easy to do so. Training team can help provide training materials if needed. Contact Ross Van Til for information or questions related to that. And thanks to the OCLO, the GEO and LEO programs who put this together. Let's see, first a few words about John's before he starts his presentation. After a 20-year commercial fishing career in Southeast Alaska, John's pursued his passion for glacial hydrology, earning degrees from the University of Alaska Southeast and Alaska Pacific University. He spent over a decade with the U.S. Geological Survey in Alaska before joining the Weather Service Alaska Pacific RFC as a hydrologist in 2020. Outside of work, Johns enjoys trail running, long-distance biking, often limited only by his dog, and playing old-time banjo. Johns, welcome to the Satellite Book Club. The floor is yours.
All right, thank you very much. I guess good morning, folks. I know it's afternoon for most.
Johns just wanted to check. We heard you for a moment, and
there we go. Okay, sorry about that. Yeah, this is a great opportunity to present, talk about the Mendenhall Glacier and Valley in a place near and dear to my heart. We're going to talk about monitoring and modeling communication strategies that we developed between the National Weather Service, some research and community partners locally and across Alaska for improved awareness and decision support services. For the folks that are impacted during these now annual Glacier Lake outburst floods, I have to tell you, next slide. Please. There we go. So there's a lot of contributors to this. Only a few of them are listed. And then, so we need to acknowledge those and the Tlingit people of Southeast Alaska, where Juneau and the Mendenhall reside. Next slide, please. Just a quick overview. Define a couple of terms just so if we're using acronyms, we know what they are. I'll kind of show you where the Mendenhall Glacier and the river is near Juneau, Alaska. Talk a little bit about the Glacier Lake outburst flood forecast history for the Mendenhall, some of the challenges that we faced, methods that we've used and how they've evolved and improved over time, and then really kind of highlight the Weather Service and partner decision support services that have also evolved over time. Next slide, please. So a glacier dam lake, for those who aren't familiar, is they can form in many ways, shown here in Jacob Bendel's cartoon, and so we can have moraine dam lakes, landslide dam lakes, But today we're really focusing on ice dam lakes that are formed when tributary glaciers retreat away from the main stem glacier. And they leave kind of a cirque or an evacuated basin where snow melt and glacier melt, precipitation runoff can accumulate throughout the melt, or what we often call the runoff season. And that's the area, I don't have my cursor available to show you, but that's the area that is outlined in the purple box. Next slide, please. So, you know, these glacier dam lakes are really just another lake within a watershed until their capacity exceeds the basin volume. Then we have a glacier like outburst flood, or a GLOF, as sometimes affectionately called. These will occur when accumulated runoff fills that glacier dam lake, that tributary evacuated basin, and it either overtops the glacier dam or hydrostatic pressure exceeds the ice overburden pressure. It might cause the ice dam to float, and we can have subglacial water release. We can also have it run along the glacier margins, the edges, or through the glacier in these open conduits, often called moulins. So once that pressure exceeds the hydrostatic pressure being pushed with, by the glacier, we will evacuate that, and often it occurs very rapidly. Next slide, please. In Alaska, so here's Alaska. Most of our glacier dam lakes are concentrated in the coastal regions, maybe some up in the Alaska Range, which is there south of Fairbanks. But we have about 120 GDLs that have been identified, and they release on a following pattern. So typically most release on a maybe 1 to 3 year recurrence interval. Most of these glacier dam lakes are in really remote locations, and therefore we need to use satellite imagery for monitoring pilot reports, looking at this historical recurrence intervals, and downstream hydrographs. And most of the time, our flood impacts typically range from kind of minor to moderate, although, as I'll tell you in a bit, that hasn't been the case for Mendenhall. Most literature review suggests that these GDLs release nearly 100%, so a full volume of their basin every time. So like the maximum amount of water that is in the basin at the time when that hydrostatic pressure exceeds the holding capacity, the basin will release all of that water. But up until 2023, there was one known exception, and that was the Mendenhall Suicide Basin near Juneau. So next slide, please. So Juneau, Alaska is on the mainland. It's Alaska's capital city. It's in the southeast panhandle, Alexander Archipelago of Alaska. It sits in above the deglaciarized Mendenhall Valley, which is shown there in the image to the left. There is a proglacial lake at the toe of the Mendenhall Glacier, which drains, if you will, is a tributary to a 4,000 square kilometer Juneau ice field, which extends all the way over into British Columbia. Mendenhall Glacier, as many of our glaciers, is one of the is rapidly retreating. It's deflating, meaning its surface is getting lower, and that is affecting tributary glaciers that are flowing in and out of the ice field and in and out of Mendenhall. The Mendenhall Glacier may be the most primary tourist attraction in the Tongass National Forest, and the U.S. Forest Service operates the Mendenhall Glacier Visitor Center there and gets about 700,000 visitors annually. It has rapidly retreated, in my tenure, 35 years of being in Southeast Alaska. And the flood impact zone, so Suicide Basin and Suicide Glacier are identified, and we'll look at these a little closer in the red box at the top. And so the flood pathway for the Suicide Basin Glacier Dam Lake is the red arrow that is also identified there. It flows into the lake, and then at these Glacier Lake outburst floods, the flood impact zone is the Mendenhall Valley, which is in the lower, approximately the lower red box. I think we can go to the next slide, please. So here's another picture courtesy of our partners at University of Alaska Southeast. You can see the Mendenhall Glacier up to the left, and the Suicide Basin is where in the foreground, and the Suicide Glacier, you can see up in the upper right hand corner is the glacier that's retreated, and then the inflow from snow melt runoff into Suicide Basin is coming down the blue squiggle, and it's filling up that basin over time. This GDL had been identified, but only as a basin, not as a threat, until 2011, which was the first Glacier Lake outburst flood that occurred, and annually it has released ever since. But again, before 2023, it had never released its full volume, which made it unique among the Glacier Dam lakes that we knew of in Alaska. Next slide, please. Here's another schematic showing the Mendenhall Glacier, and you can see kind of the ice flow from the Mendenhall, depending on that hydrostatic pressure, can push into the Glacier Dam Lake or into that basin, and it can also push past it. And that is a factor in controlling the volume of water and ice, sometimes referred to as Berge bits, and the amount of calving or glacier ablation, ice ablation into the Suicide Basin itself. Again, you can see inflow from Suicide Glacier up there in the upper left, or excuse me, upper right, and some ice floating. The USGS has operated a gauge up there since about 2014, and that gauge has evolved over time. We can look a little bit more at the instrumentation there on the next slide, please. So here we can see this is the basin pretty much as it when it has emptied. There's not a lot of water left in here, and there's a weather station. There is a bank-mounted laser gauge that is measuring pool elevation, so water and ice elevation within the basin. That gives us, allows us to know and estimate what the volume of water is in the basin, and helps us understand what the potential flow coming out could be should it release. And we'll talk a little bit more about that later. There are satellite cameras that are taking pictures of both the of the water level and the ice level within the basin, and then also with the glacier pushing into the basin, and that gives us an idea also of volume. And then a submersible pressure transducer measuring high water pool elevation as well. There's a lot of redundancies. Everything is transmitted by satellite communication, and it's helicopter access only. So it's a pretty challenging place to work. A lot of what we do and what we need for monitoring these Glacier Dam lakes, and specifically this one, all comes with remotely sensed data. So next slide, please. And sometimes it's really difficult to to get up there and be able to like see firsthand what's going on. So we do throughout our GDL season, if you will, we review Sentinel-2 imagery via Copernicus, and it's pretty essential but we're kind of limited to cloud-free days, which is a difficult thing in especially Southeast Alaska. It's the most northern temperate rainforest in North America, has about 280 cloudy days per year, about 230 days of measurable precip for about a 72-inch average precip annually. So, you know, here's a 2023 example leading up to the first full basin release, which occurred on August 5th. And so you can see here, we were lucky, we got a few images, and I failed to actually outline this, I apologize, but kind of under, you know, up by the day in each of those dates, you can kind of see the evolution of a small pond growing, and that's just water storage. And so we're using that to sort of watch where, like, how much water is filling in the basin if we can't see the basin itself. And it's just one more tool in our toolbox using the satellite imagery from Sentinel-2. Unfortunately, the basin's pretty small and it's complicated. So like SAR, Sentinel-1 imagery isn't really useful for us, at least at this time. Next slide, please. Downstream, so in the map on the right-hand side is, you can see the toe of the Mendenhall Glacier, and identified as where the GDL would flow from along that east-southeast margin into Mendenhall Lake, where the USGS has operated a river gauge since I think 1966, and just a cartoon showing sort of what that river gauge would look like. It's just measuring pressure in the lake. The lake actually is great because it acts as a big stilling well, so the data are pretty good. And then that's worked up or transmitted via satellite, in this case every 15 minutes. And they produce a stage hydrograph and put it on NWIS. And in this case, the hydrograph in the bottom right is July through August of 2024 with elevation relative to gauge datum on the y-axis, and through the 2024 peak of record, which we'll talk about a little bit more in a bit. The shaded areas are the National Weather Service flood levels. And just for context. Next slide, please. So in order to forecast, we can't forecast just knowing stage alone. So we have the USGS measures the river and produces a stage discharge rating model. So in this case, we have river stage, again, relative to arbitrary datum. So on the y-axis, and on the x-axis, we have river discharge or flow, cubic feet per second. This shows sort of that, and we can't measure flow in like near real time either. So we have to use these models. Dynamic glacial rivers would be even more difficult for measuring anything in a real-time manner. And stage is just relative. Again, it's an arbitrary datum. So in order to forecast or do water balance modeling, we have to have a discharge. These models change over time, either from dynamic fill and scour of the channel, or they can change when a higher or lower discharge is measured. And in this case, you can see the two curves, and the one deviating towards the 2024 peak of record, and then the other one sort of jutting a little bit more vertically, a little steeper to the left of that, and that change was the result of being able to measure, or having an event with a lot of water and being able to measure that accurately. And then that allowed us to update all of the models that we use in the forecast process. Next slide, please. So how do we build these forecasts? You know, we have to start with looking at past events. So we look at these post-GLOF flow events. We use a gauge analysis tool developed here, APRFC, and we separate the Glacier Dam Lake event flow from the base flow, as you can see in the left figure. And then, so the data that we're seeing here is observed USGS data through the event flow, or through the event. And then we use these to take these separated GDL event hydrographs out to build an event library that we can then use in the RFC CHIPS forecast model, and build off of that. So you know, this is, we had done this for about all 47-ish Glacier Lake outburst floods since 2011, and built this library. So next slide, please. So our Glacier Lake outburst flood or forecast is going to be the sum of our rainfall, melt, and base flow forecast. So that would be just our normal forecast, right? That would be if there was no Glacier Lake outburst flood on top of it. And then we add the release volume of the event. In pre-2024, and I'll tell you, like, pre-2024, we did this out of this GDL event library. These were all these separated events. So we would look, we would collaborate with our forecast office in Juneau, look at these analog historical events and select the best fit curve to add to the model. This was great. It was chosen based on like estimated lake elevation and volume, but it wasn't something that was measured. So it was really subjective, and it might change over time. So like in the figure here, we have just sort of our, you can see the event that we push from the event library, we add it to the overall hydrograph, and that becomes, you know, the forecast. Biggest problem with this was that we couldn't ever forecast higher than anything we hadn't observed. And so this really wasn't a big problem until 2023. So next slide, please. So after 2023, again, as a reminder, that was the first year that we had a total volume release of Suicide Basin. Well, what that allowed us to do, and our partners at University of Alaska Southeast, was to go up and fly LiDAR in the basin with a drone, and produced a digital elevation model, which was the first time we had like a full basin model or a near full basin model of Suicide Basin. And that's the DEM in the upper left-hand corner. And that was 3 days after. We knew that it was a warm period. It was August, and we had a bunch of snow melt, glacier melt runoff. So we didn't capture the very bottom, and that was okay. We made some estimates for that. Then over time, we've been tracking this. So they were able to continue going up and measuring and revising this DEM. In August 6th, 2024, we had another peak of record flood. This time, UAS was able to, and USGS were able to get up there immediately and fly this the basin again, and produce a new DEM that again we were able to then refine the model. Well, next slide, please. So From the DEMs, we then were able to produce a storage elevation curve. And you can see here on the left-hand side, we have elevation of pool elevation in the GDL on the y-axis and volume on the x-axis. And from this storage elevation curve, estimate the volume, an accurate volume in the basin. But we also needed to know what is the elevation of the basin. So USGS efforts, either using a camera with a virtual staff gauge that is taking a picture at the far wall of the GDL, is then used to estimate what the water level is. And then the USGS laser gauge supplements that and allows us to know and estimate what that elevation is to put into this storage elevation curve. And all of this helps us define what the pre-release storage, either is or was, and it's the maximum release storage that we're really concerned about. Next slide, please. So here is kind of past Glacier Lake Outburst flood event distribution. So this is taking like most of the biggest events or most of the cleanest events. And for scale, we've got discharge on the y-axis and event hour, so 0 being the start of the event, on the x-axis. And what we started to see was a pattern, and the pattern is that if you deliberately shifted the Mendenhall River peak flow event hydrographs with the base flow removed and align them on a 48-hour crest time frame, each of them was essentially a scaled representation of the other. The only difference was that the volume water released was different. So this was pretty significant because this distribution suggested we might be able to assign, or well, by being able to shift these, it gave us a model that we might be able to scale by volume. So now we have 3 different parts. We have the volume elevation curve from a DEM that we were first able to start working with in 2023 and have been refining ever since, especially after the massive peak in 2024. We were able to develop a storage elevation curve based on that and have the data from USGS to give us pool elevation to estimate an accurate volume. And now we can say, all right, well, we have this distribution of scaled curves. So how can we make this work and benefit our forecast tools? Next slide, please. So this was also something that we noticed in 2023, and it's still worth talking about in that it reiterates just how unique Mendenhall was in that, interestingly, with this new empty basin, quote unquote empty basin that we had from the DEM in 2023, it revealed that like 11 out of 14 Glacier Lake Outburst floods between 2016 and 2023 released only approximately 20 to 60% of the total volume in the basin. And this was pretty significant because what that distribution suggested pre-2023 was that we might be able to assign some sort of historical likelihood of volume expected to release. But we needed a curve and a set of curves in order to sort of apply this to with the volume that we had. And I'll talk about why this didn't work fully in a minute. So next slide, please. Okay. So we have a lot of information here that we've sort of deliberately made, and we've taken this these curves, our 2024 curve, our 2023 curve, and we've said, well, if we align them at 48 hours, we can and we can just scale these by volume. So we were able to build a scaled nest of discharge curves. And this was important because this allowed us to put this into our forecast model. So rather than relying upon an analog event and sort of being subjective about what event we chose to apply to the official forecast runoff, rainfall runoff forecast, we could actually we had more skill in what we were able to forecast and how to produce those forecasts. So by taking all this information, next slide, please. Back into Chip's model. So this actually, I think, is just from yesterday. So this, we know what the volume is yesterday. So we're able to produce a forecast scenario, and we can do this on any time step within the time step of the model, and we can add the GDL volume addition based on a scalar, one of those curves in that curve nest to our hydrograph. And so we take our GDL pool elevation, we compute a volume, and that is automatically applied to the rainfall runoff forecast. We can also push that from the historical event library. So in this case, right now, we have about 10,000 acre feet in the basin, and maybe a little bit more, and that that curve then can extrapolate into a forecast scenario. Next slide, please. So our forecast scenarios pre-last August were included, and so we'll return to this this distribution, this 11 out of 14 events, and included this what we called the release volume range, or historical release volume range, from 2016 to 2023. And what we hoped that would do would kind of give a sense of where we thought the basin, how much water would come out of the basin just based on a distribution. What we have seen, and so in this forecast scenario, which is shared with partners on a daily basis, and this one was the one that came out right before it released last year in August, and so this is our peak of record. We had our observed USGS data. They're outlined in black. We have river flow on the y-axis, time on the x-axis. We have our flood stages identified, and we have a total release volume. So that's our maximum release. It outlined as the tallest curve in there. We have the official forecast, so that is just the rainfall runoff forecast from the model without the addition of the GDL flow. And then we had this release volume range. All of this information was taken from our satellite camera, virtual staff gauge, using the DEM satellite imagery that we had reviewed, and the laser gauge that all partner research partners working together to supply these data. Well, in 2024, we released the full basin again. So full volume, record flow, and it allowed us to, I guess we should go to the next slide. What that allowed us to do was, like in 2023, we had our initial forecast. That's our hydrograph on the right hand or left hand side is 2023, and each of these curves is a subsequent forecast. So each time step that we issued a forecast, it was always we always were chasing this curve. Because we couldn't forecast anything larger than we had observed, and so the forecast skill wasn't very good, and it didn't leave us with a lot of confidence in going forward. With the improvements that we made in 2024, we could estimate the GDL volume, we could apply a curve into the model, and as we can see on the right-hand side, we forecast a little under what the peak would be, but the shape of each of the forecast curves was relatively consistent through the entire event. And then the AHAPS hydrograph from 2024 shows the peak there. What we determined after, and so next slide, please. So as we move into, how we're forecasting now, said it a bunch of times, but the Glacier Lake Outburst flood is our base flow rainfall runoff forecast plus a GDL event addition of the maximum volume curve. So this is yesterday's forecast scenario. We produce 2 images a day or as often as needed, and we have removed any sort of estimation of likelihood probability based on historical data. At this time, the Mendenhall has probably changed, and it makes more sense to only ever present what the maximum scenario would be. And so moving forward, that's APRFC strategy. I'm going to just run through a few more slides here to kind of show some of the oh, there is I didn't know there was an animation in here. So the throughout the events, like, it's really important to keep folks aware. So there's public near real-time data access communicated by the National Weather Service through the Suicide Basin monitoring current conditions page. The URLs there at the top right. The USGS is putting up images that are then put into a time lapse. This actually time lapse is running and shows the basin releasing last August. But there's some information in here, current hydrographs and images. Next slide. We also, our UAS partners, the University of Alaska Southeast, have developed a new community dashboard. So like this glacial flood dashboard has links to some of the remotely sensed data. It has some really good, like, FAQ, simple GDL, Glacier Lake Outburst flood fundamental questions, either specific to Mendenhall or just glaciers in general. And that has a visualization tool to view new flood and inundation maps that were developed in conjunction with the City and Borough of Juneau, or CBJ, Army Corps engineers, and private consultants in the National Weather Service. Next slide, please. So here's an example of the Mendenhall Lake at 16 feet. So the 2024 flood was just under 16 feet. That's well over major flood stage. And you can see the inundation of the Mendenhall Valley. And what's nice about this is that you can change, it's interactive. You can change this so homeowners and people in Juneau can look at where's moderate flood stage and look at the impacts that are listed by National Weather Service on the NWIPS page. Next slide, please. The City and Borough of Juneau has also put up a Mendenhall inundation map information page. These were done with a lot of research partner collaboration for the verification of high water marks from past events. So this is a pretty good dashboard that again, research partners are using to improve the public strategies for DSSS for these events. Next slide, please. and all of that can be used either like before or after these the flood occurs. Mid outburst flood community outreach is really driven by National Weather Service, whether it be these live videos, and flood warning updates that are presented on social media and across as many channels as possible to both inform, educate, and warn people of current conditions and what they should expect. And then throughout a lot of this, because these flood inundation maps have been updated, the city and borough of Juneau is took extra steps. So next slide, please. To do a fair amount of flood mitigation in the form of a HESCO barrier levee that they installed on the east bank, or the more populated bank where the folks live. On the left-hand side, you can see a modeled flood inundation, again at 16 feet, which was verified by high water marks. These were from 2024, and how far that water extended into the valley, homes and residences. And then the right-hand side shows the modeled inundation and how flood flow is being forced over the west bank a little bit more, and protecting a lot of those homes. And again, so like strategies for protecting our residents in Juneau. Next slide, please. So just in summary, Glacier Lake Outburst flood forecasting is pretty dynamic. It requires physically based models, but it's also, they have to be based on measurable parameters, or the forecasts can be extremely subjective. Post 2023 Glacier Lake Outburst floods, so when we finally emptied the basin for the first time, we used expertise of Weather Service, River Forecast Center, our research and community partners to improve the forecasts and the messaging both before, during, and even after events, with community meetings and awareness and discussions, so that people were aware of what is what the potential is if another one was to go. I should mention that it's not just one flood a year. It's usually the last couple of years have been one very impactful flood, but the longer it fills, the more water is available for it to release. We've increased data monitoring and near real-time data access and visualization through those tools that I've showed. Impact assessment have been updated based on each year's subsequent impacts to make sure they're the most accurate and are communicated that way effectively. And the official river forecast has changed to drop any sort of probability distribution. But our next steps really are trying to develop some sort of probabilistic messaging. It's obviously a goal of the Weather Service, both to communicate the timing, the risk, and the impacts in sort of a probabilistic manner. And then the flood inundation maps and extents and impacts are done. They did those much quicker, I think, than everybody had hoped. So hopefully this was interesting. I think that's all I have. Next slide is just saying thanks.
Okay, well, thank you, Johns, for something that we probably don't hear about a whole lot down on the lower 48, but something certainly different and impactful. One thing maybe we can stay on a little bit for some questions as they roll in. Just a reminder to stay on if we can maybe extend this for a little bit longer than normal, and we encourage anybody from field forecast offices and regional headquarters to ask questions. And as always, we encourage you to change your layout to tiled and select hide tiles without video if you can, please. And so the other thing is to remember is for next week, we have, that would be Thursday, June 12th, Chris Smith, the GOES-R satellite liaison, will be presenting on the May 2025 Eastern U.S. Atmospheric River event, which is certainly, we usually think about Western U.S. Atmospheric River, so you're not going to want to miss that one. So now, and let's see, so also if you have any questions about the SBC or configuration of satellite products, please contact Kishad Bowman or Emily Maddox, and they will get back to you. So if we have a couple time for maybe a couple questions, one thing that came up, Johns, you said, you had quite a few partial releases, and then those in 2023 and 2024 were a full release. I'm curious as to what was the impact on the public in those differences. You showed some maps, but I'm just curious if you had, damage numbers or something like that for a partial versus a full release.
Well, partial release could be, you could have 60 or 70% of the basin releasing, but in those 2 years, the 2023 and 2024, I think there was roughly, I might not get the numbers wrong, but I'll say around 100 homes that were impacted with flood damage. If we had time, there's some pretty amazing videos of the erosion along that east bank or that left bank of the river facing downstream in 2023, and so a little bit more impactful as far as bank erosion went that year. In 2024, though, the inundation was higher, so I think there's over 300 homes that declared fairly significant moderate to major flood damage. It was just having that much more volume. It's an additional 10,000 acre feet of water that was released. The flood flow was another 10,000 CFS. Base flow in this river is roughly 3,000 CFS throughout the summer. So we're tripled or more than that.
Right.
So the scour in the channels and along the banks was pretty significant. Not to say that 2016, which was I think only around 40 to 50% of the total volume in the basin release was also very impactful and did have some flooding associated with it, but not anywhere near what we've seen in the last 2 years. Sure.
Okay. And so I don't know if you really mentioned this, but in terms of just sort of seasonal forecasting, how do you get a feel for what might happen this year? 2023, 2024, 2025, is it, from this point, can you give a, we're not going to hold you to it, but have a feel for what?
Well, we're looking at a lot of the same metrics that we would do for most rainfall runoff forecasting, which is, what's our snowpack like? Right. How much, how warm are we expecting? We're looking at CPC outlooks for temperatures that really drives the glacial melt. We're still snowing at elevation in Southeast Alaska right now. We've been pretty cold across the entire state. And so it's going to take a little bit more time for that snowpack up there to ripen and start to melt. So we might be a little delayed in when we expect this to go. But the dynamics of these systems are such that we don't know. There's different mechanisms for where and how this thing will release. So we could have to fill all the way to our dam height of the glacier and overtop that, and then start releasing water that way. We might also just have the glacier run by and there be a conduit that allows water to release. The glacier. A glacier is a river of ice that's flowing all the time, and so as the Mendenhall passes, it could open up, a conduit that already exists in the glacier from somewhere up glacier and allow some water to go out. We are prepared for another, record flood, and we'll communicate that as the basin fills, and our forecast scenarios will reflect a full maximum release. We do know that the dam is lowering on the glacier, so that the elevation of the glacier is lowering each year.
Okay.
We've seen that consistent, or staying relatively the same, but that all depends on how that glacier pushes into the basin and how much water then can fill in between where the basin starts and the glacier starts, and what that channel is there. Like, that environment is really, really difficult to work in. It's very crevassed. You can't get on the glacier to do, say, glacier penetrating radar measurements and look at what is the bathymetry of the bedrock beneath it. I mean, there's just no way to really access that without, well, you could try it with helicopters, you can try it with other tools, but it's expensive and dangerous.
Okay. Well, I don't see any questions coming up in the chat, but maybe, so for those who may want to look into this more, it sounds like if you go to the Juneau National Weather Service office, we can get some more information, and that can lead us into looking at some of these plots and keeping an eye on things if we want to over the summer.
Oh, for sure. Yep.
Okay.
Juneau National Weather Service Juneau has a page that, again, they have their own dashboard, and it will link to all those other dashboards if anybody wants to explore it. The Alaska Pacific River Forecast Center also maintains the Glacier Dam Lake library on its website, and for not just the Mendenhall and the Suicide Basin GDL, but for all these in Alaska.
Excellent. Okay. Well, thanks again, Johns, and I will turn it back to Brian to wrap things up.
All right. Thank you very much, Jack. We appreciate your facilitation of today's seminar. Thanks to John as well. We thank you for this walkthrough of rich graphics and illustrations of this very unique and very high impact threat, tools, data that you use to characterize it and forecast its evolution. As Jack informed us, next week's book club presenter, Chris Smith, will present a seminar on the May 2025 Eastern U.S. Atmospheric River event. We're barely dried out, and so we want to hear the postmortem on that. Encourage you to join us next Thursday at the same time. With that, thank you for joining us. We'll wrap up today's call right here.